All right, so first up, I have this nice little pretty picture here. This is the sun, and this is the Earth rotating about it. So the first question that I'm going to be solving is calculate the velocity of the Earth around the sun. This will deal with circular motion since it is in orbit. So the velocity will be equal to the number of revolutions times 2 pi times the radius divided by the time. All right, so all I've really been given is that the distance is 150 million kilometers, which will go to 1.5 times 10 to the 11th meters. However, we know from basic science that the time will be 1 year. That's how long it takes Earth to rotate around it. And the mass, it's also known by Earth, is 5.972 times 10 to the 24th. All right. So I'm not going to really bore you with just plugging in those numbers there for the velocity. But once you do, also the time, the year, we converted that to seconds. So 365 days times 24 hours per day times 60 minutes per hour times 60 seconds per minute. And you will come out to just under 30,000 meters per second. Yeah, the Earth's in a hurry, I know. The second question is going to be calculate the gravitational force from the sun on Earth. All right, so the gravitational force, at least with circular motion, is going to be equal to the mass times that velocity, the circular motion velocity squared, divided by the radius. And once more, this is just plugging in these numbers for that, and you'll come out to about 3.556 times 10 to the 22nd newtons. And finally, I went on a different bit of an angle here just to kind of show a different way to come about this. The question is, what is the frictional force acting on each of a 600 kilograms car's tires to ensure it can go around a 50-meter radius corner at 60 kilometers per hour? So the first thing, I converted that 60 kilometers per hour is going to be 60,000 meters divided by 60 minutes times 60 seconds per minute, which is, I just kind of left it in that just because it's a calculation anyway, just going to throw it in my calculator. So I have a picture here to really describe it. So if we were putting this on a graph, the curve, the radius is going to be 50 by 50, and this is, the car going around it. So the total friction is going to be equal to the mass times the velocity squared divided by the radius. And I do have that written out right here. That'll come to about 3,333.33 repeated, but we ended it with a 4 newtons. However, the question did ask for each of the tires. So you'll just divide that number right there by 4. And per tire, the frictional force should be 833.33 newtons to ensure that it will safely go around this corner.